Hi, Shine Guy here. This is going to be my second video. I've been interested in the Don Smith technology for quite a long time, and you can see that I have done, well, kind of an insane amount of work to learn radio frequency engineering, I suppose you could call it. I had to teach myself electronics a lot. I studied a little electronics as a kid, but I had to learn it again, and oh boy, I've been doing this stuff for years. You know, I did Bedini replications and decided that ultimately I needed a little bit more control over resonance, and I needed to be able to see exactly what was happening, and I wanted to, if I was going to work on anything, work on a system that generated a lot of power. So that led me to the Don Smith devices, and the similarities between the Don Smith devices and Tesla coils is absolutely uncanny. And if you read Patrick Kelly's article about the Don Smith, he says very clearly that it's a Tesla coil. So I've been learning about Tesla coils as well. Haven't actually made one yet. Have spent most of my time learning how to drive coils and drive flyback transformers, and I only get to do this part-time, so that's too bad. I'd love to spend more time learning about this stuff because energy is probably my #1 passion. In any case, what I've done here is I've created a ZVS driver circuit for this flyback, and this is the circuit here. I've done the ZVS circuit a number of times. This was my first attempt at the ZVS circuit, and it worked quite well, but I was a little bit naive about connections, and I didn't really understand how the circuit worked, and I have spent a lot of time studying the circuit, and I understand it quite well. In any case, I'm using it to drive this flyback transformer here, and I thought it would be easier the second time around. It still took quite a bit of work to get it to work, and ultimately what I'm doing is I'm building a high voltage power supply. Ideally I'd like to make an adjustable high voltage power supply so that I can just set the voltage level. And the thing that's special about this, and the reason that I'm not using a what do you call it, one of these neon sign transformers, is that the well, I've got a whole bunch of them back there. Sadly, I've spent a lot of money on this crap. It's a little bit of an expensive hobby. In any case, the reason I'm not using a neon sign transformer is that I have no idea how it actually works inside. I've cracked it open and I see that there's a flyback transformer in there, potted in some heavy-duty high-voltage insulation and resin and such, but the driver circuit is something that I don't understand, and they've installed all these ground fault tolerance circuits in them, and I really wanted to, if I was going to build something, make sure that I understood every part of the circuit. So that's what I've done here. Oh, and the other big thing about this is that this is a resonance circuit. I really don't know how they drive those flyback transformers, if they actually drive them at resonance, or if they drive them at some other frequency within the range of the capacity of the flyback transformer. But when I used this, when I was messing around with this, I got some fabulous arcs, and I was able to drive it actually at high voltage. This is a high voltage power supply that I've built. It's a half bridge, and those are really big capacitors in there. That's an extremely dangerous power supply. So I actually kind of wanted to produce a power supply that was a little bit less dangerous. This is something that ideally you can shut off. You can see that this is the ZV